whichever. It doesn't matter. They're both. We started with the quiz. You can use your notes in your homework, but your time's going to be an issue. Yeah. Yes?
I need my phone to log into my computer and log into my ACES. It's saying that it needs to send a text.
Okay, that's fine.
Are you sure?
Yeah, that's okay.
Cool.
Yes.
Are we allowed to attempt? Are we allowed to do both, or is just doing one at a time?
You feel good about that?
Yeah, good.
Yeah? All right, just turn that. Yeah, that's right. You're good.
What day is it today?
I'm sorry?
What day is it?
19th. You got 4 minutes. Okay, thank you. Okay, thank you. Just sit right here, please. Thank you. Thank you.
Do I need to circle the answer?
Nope. Okay, thank you. It's right there. Thank you. Okay, thank you. Go 1 more minute. Okay, thank you. Let's see here. Thank you. Thank you. Okay, I need what you have, please. Thank you. Thank you. Thank you. Thank you. God dang it, where is it? Okay, thank you. Oops, thank you. Anybody else? Anybody else? Last call? No? Everybody's turned in the quiz? Okay. So let me show you real quick what the answers were to that. If I can get this to come up here. Okay, so let's look at the first one here. Sorry, I mean, I wish I could do better here with the board. So difference quotient, you're using, hold on, let me do this. You're using a formula, hopefully that was in your notes. It's as bright as it goes, okay. So your first, you gotta figure out what f of x plus h is, right? That's what I showed in class, do that first. So I did that over here, scratch work on the side. So in doing that, let's see if I can move that, if y'all can see that okay. You're replacing x plus h into the original function, and then you have to square this x plus h first, then distribute a 2, and then distribute a -4 through. You get this big ugly thing. That's going to be the top left of this difference quotient. So I put that right here. And then I subtract from it f of x. That's the original function. Then you have to distribute the negative through. And then a bunch of things cancel. And you wind up getting just this up top. You factor out an h, GCF. H cancels. You're left with this. Yes?
You get 2x squared.
2x squared. Oh, you know what? That's an x. I'm sorry. That's just x.
Okay,
My
that's
apologies.
x.
Right there. I don't know why I put it squared. Yeah, that's supposed to be 4x, right? What the hell did I do?
I was having a moment because I saw it and I'm like,
Okay.
I forgot to bring it down.
Yeah, no. This line's right. This one, I have no idea what I did there.
I got all the numbers right. Forgot
You know
to-
what happened was, right? I know what happened.
Yeah.
No excuses. I hate excuses. But y'all know about my dog. Okay, so my wife texted me right when I was doing this morning, and I had left my black shorts on the bed, and it looked just like her little dog, because she had a dog. You know, our dog was a little black Pomeranian. So she woke up and like saw it and like started crying and called me and stuff. So I think I got distracted. That's my excuse. I got distracted. That's what it was.
So it's just 4x.
It should just be 4. This should be 4x plus 2h minus 4. Yeah. Okay. Now on the other one, the quotient. The first part was easy. You just put the f over the g and just put one on top of the other, and you're done. The hard part's the domain, because you got to consider two different things. First, you know that because you have a radical, the x minus 1 underneath has to be greater than or equal to 0. And then you add 1 to both sides, and that tells you that x has to be greater than or equal to 1. So far, any number greater than or equal to 1 will work. But then you have to look at the denominator. The denominator can't be 0. So I say, all right, well, the denominator can't be 0. That means x can't be 5. And so it can be anything except 5. And then you have to look at what do these both have in common. So you have to satisfy both of these at the same time. So any x that's bigger than or equal to 1 forever, but you can't have 5. And the way we write that is like this. From the looks of it, only a few people tried the second one. So anyways, that's the quiz. Asked you to do one problem. I gave you 10 minutes. That's the amount of time I think it should take you to do this problem. No more than that. It should be probably closer to about 6 minutes to do that problem. I'm just thinking about our test, right? Which is what, next Thursday? Next Thursday, right? And how much time it's going to take you to get through the test? There's an expectation that you work at a certain pace, right? This is not just like if I give you 10 problems and give you 3 days, can you do it? It's, can you do that in a certain amount of time? Yes. Our whole class period. 1 hour, 40 minutes. Oh, the test, I haven't made the test. The number of questions isn't really that important in terms of, I know that's what you want to know, right? What I do is I make the test, I take the test, and for a class that's an hour, 40 minutes, 100 minutes long, right? I should be able to finish the test in 20 minutes. If I can finish it in 20 minutes, the expectation is that it should, right? 20 times 5 is 100. It should take you 5 times longer than me at the most. That's the way I do it. So if I make a test and it takes me 30 minutes, I'll trim it down. If it takes me 10 minutes, I'll add a few, no problem. No notes on the test, no. What? No. I mean, look, I mean, I'm trying to, like, I've tried to, like, kind of ease you into this, right? Like the first quiz was right over a problem right out of your notes, right? Right out of your homework, right? So, but the expectation is that you learn the material and you can come in and you can execute it, right? You are all STEM majors, yes? Yes, right? I mean, yeah, I mean, you're all on the STEM track, right? So the expectation here is that you can do this, right? That you can do it. There will be a review. I will provide a review for you, but I will not, like, go through the whole review in class. So you will have a review. That will help you narrow down what to study. But other than that, you're just going to need to come in and be prepared, right? So, all right. Seems kind of doomy and gloomy in here right now. What's going on? All right. All right, so what are we doing today? We are going to finish up. What is it? 3.2. We're going to finish up 3.2. And I really wish this board went all the way up, but this is the way it is. In some of the other rooms in the other building, the board goes up, so it's a lot nicer. We don't have a seam in the middle, but we're going to make this work. So what we're looking at, what we were doing in 3.2 is we were talking about functions and evaluating functions. We're going to look at this graph right here is a function, all right? It represents a function. And we have these questions over here on the side that we're going to go through one by one, all right? So let's look at this and contemplate what each of these points on this graph represent, right? So I'm just going to pick one of these points right here, the point 5,3. What does that 5,3 represent to us? It means that for this function, if I plug in 5, I get 3, right? That's what that point represents here. So my input, right, this is my x, and this is like my y, right? Input, output. And from that basic idea, we should be able to answer all these questions. So the first question here, part A, says find f of 0. I'm going to do this right here. So it says here for part A, find f of 0. All right, so you look at this, and what you're looking for is where on this graph is your x coordinate 0. So you'll see it right here, right? It's the origin right here. So when you plug in 0, what do you get? 0. You know that from this right here, right? 0 goes in, 0 comes out. So the answer is 0. All right. Now they want to know what's f of 6. So you plug in 6 right here, right? 6, 0 means 0 comes out as well, right? Is this pretty straightforward for everyone?
Yeah, it's just input output.
Input, output. Okay, now, part B. Find f of 2, f of negative 2. I got those Yeah, I got those right. Okay. So f of 2 is what? Negative 2, right? When you plug in 2, you get negative 2. And what's f of negative 2? So when we plug in negative 2, we get 1. Right? Just give you a test like this, right? Give you 30 problems like this on the test. You'll all be happy?
Yes.
Yeah. Okay. 3. Is f of 3 positive or negative? Yeah, so you go to 3. Where's 3? Right about here? Now, they don't give you the exact point, do they? But you can tell that at 3, the point's down here. We don't exactly know, we don't exactly know what the y-coordinate is, but I can tell you it's below the x-axis, right? So I know that it's a negative number. Okay, how about D? Is f of negative 1 positive or negative? So f of negative 1 is about right here, negative 1. And the point is there. Again, we don't know what the y-coordinate is, but we know that it's above the x-axis, so we had to go up, right? So it's positive. We all good? Yeah? No questions? Let me,
One,
okay.
whenever you say f of x, you really just mean x points, and then the y points like that.
F of x, no, when I say f of 0, I'm saying what's the y value when you plug 0 in for x,
Okay.
right? When you say what's f of 6, you're saying what's the y value when you plug 6 in for x.
Okay.
All right, where are we? E? All right, so for E, we're asked for what value of x is f of x 0? What value / values of x is f of x equal to 0? So this is the first time we've had a problem like this. Everything else has been plug in the x, get the y value, right? What they're giving us here is what? The 0 is the what? The x or the y value? This is the y value, right? And what they're asking us is what x do we plug in to get a y value of 0? So look at your points, and you have to list all the points where your y value is 0. And there's multiple points, aren't there? There's this one, right? This one, and this one, right? There are 3 different x values. What's the x value here? 0. X value here? 4. X value here? 6. So our answer is x equals 0, 4, 6. I'm writing it as a list of numbers. You could also do it this way. Anytime we write a list of numbers, you can put it in a set of braces, and it's understood to be a list. This is fine, but I'm just showing you that's another notation you can use. Okay, good? All right, what about, okay, part F is a little harder. Let me see what I can do here. I'm going to have to erase this. Is that all right? Okay, F is saying, F is almost the same thing, right? It's saying for what values, so for what x, right, is f of x what? Less than 0. Less than 0. That means negative, right? So it's asking for what x values, right? For what x values is your y value going to be, what, smaller than 0, which means 2. So here,
Yes.
that's 1, right? That point definitely, yes. The y value is below. Are there any other points where your y value is below the x-axis?
Yeah.
How about here? Here, 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 here. All those, every point in here, right? Every point there, every single one of them, the y value is below the x-axis, right? Are there any other places on the function where the y value is below the x-axis? No, that's it. So how do I tell you that it's all the x's between here and here, right? Because remember, we're asking for the x's where the y is below. So how do I say everything between, where's this? 0 and 4. How do I say that? I use an interval, right? 0 to 4. Now, do I want to include the endpoints? This says we have to be strictly less than 0, right? What's happening at the endpoints? We are equal to 0, right? We want to be less than. So I'm going to say here my answer. I'm just going to do it as an interval, right? My answer is an interval, right? It's giving me the x's, and it goes from, you said 0 to 4, right? Not including the endpoints, so we put parentheses. That's an interval, everything between 0 and 4. We good? All right, part G.
Would that be with brackets or would that be with parentheses?
With what? For this question? That's what I was saying. If you say brackets, right, then you want to include 0, right?
Oh, yeah.
What's the value of the function at 0? When you plug 0 in, what do you get? 0. Is that less than 0? No, right? 0 is 0. So,
Like spaced out for a second.
okay. So had this been this, had it been that, right? Brackets. Okay? All right, look at the next question. What is the domain of f? So when we talked about domain last class, the domain are all the x's that are allowed to be plugged into the function. All the x's where you get an output, right? I talked about a car wash, you can't plug certain vehicles into a car wash. Are there any restrictions on this graph? And we need to look at it visually. Is there anywhere where this function is not defined? Are there any values of x where the function does not exist, where we don't have something, right? So let me put the problem here. G, what is the domain of f? Here's the way that I look at it. I wish I had a ruler in here. I don't have one. The way that I look at it, I do have this, hold on, is I imagine a vertical line, and I'm just going to start from the left and move to the right, and I'm going to be looking up and down and seeing if I have graph or not, okay? This is how I look for domain. So as I move from left, do I have any graph above or below? You see any points on the graph here? No, right? Because there's a solid dot, there's nothing over here. So I don't have anything until I get to where? -4. That's where I start, right? I start getting graph. So I can plug -4 in and get an answer. Can I plug in -3 and get an answer? Can I plug in -3.999? Yes. So from -4 over, I have picture, right? I have something, 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 still have something. Until when? Until 6, and then I stop. So the domain of this, again, is an interval. It starts at -4, and it ends at 6. And remember, these are x's, right? When you're talking about domain, you're talking about the things that go into the function, the x's. I put brackets, right? Because at -4, the function is defined, right? You have a point. I put a bracket at 6 because at 6, you plug in, you get 0. Questions there? H, range. I'm going to put ran f instead of range. All right, can someone tell me what the difference is between domain and range in terms of how I'm going to approach this?
Range is the amount of y values
It's-
that are inclusive within the function.
It's the y values that come out, right?
Yeah.
So what I'm going to do is instead of doing this and looking up and down, seeing if I have a graph, I'm going to turn my line this way, start from the bottom, and work my way up. So do I ever get any y values down here from this function? No? Not until I get to where? -2, right? -2 is where I start getting outputs. Does -1 ever come out of this function? Does this function ever spit out -1? Yes. Where? Here and over here, right? So -2, up through -1, up through 0. Am I still getting graph here? Yes? Where do I stop? Is it 5 or 3? 3, right? It's the highest value that we get out here is 3, right? That's the highest value. So your range went from, what, -2 to 3. And just remember, these are y's, right? These are your y's. Your range is always y values. Your domain is always x.
What happens when a point set up points is not inclusive?
Yeah, we'll look at those. We'll look at those. Okay. Is all right? Next question. What are the x-intercepts? So we have not formally defined what an x-intercept is in here, but I think that the idea is pretty straightforward. So we can just say what it is, right? An x-intercept is anywhere that your graph hits or touches the x-axis. So how many places do you see this graph hit the x-axis? 3 places, right? Here, here, and here. Hey, we had that answer earlier, didn't we? It was x was, what, 0, 4, and 6. Now, if we write these as points, as the ordered pairs, it was 0, 0, right? This one would be 4, 0. This one would be 6, 0. So what is it that all x-intercepts have in common?
0.
What's 0? The y value is 0. That's what makes an x-intercept. It's anywhere on the function where your y value is 0, right? Where your y's are 0. That's what makes an x-intercept an x-intercept. As opposed to y-intercepts, which is part J, a y-intercept are any points where your x is 0. So do you see any places where your x is 0? Right here, right? Right there. That point. That's the only point where I cross the x-axis. So the y-intercept would be at y equals 0, or if you wanted to, you could write it as the point 0, 0. This point. All right, questions there? All right, part K. How often does the line y equal -1 intersect the graph? What?
Twice.
So what they're asking is for you to consider this line that they have not drawn for you. You have to know what this line looks like. Y equals -1 is a horizontal line that goes through -1. That's right here, -1. If I were to draw a line through that, -1, right? That is the graph of y equals -1. The question is how often does it hit the graph? So you can see it hits twice, right? It hits twice. So twice. All right. JKL, part L. How often does a line x equals 1 intersect the graph? X equals 1, not y equals 1, or y equals -1. X equals 1. X equals 1 is what type of line? Horizontal? Vertical. Vertical, right? X equals 1 is this line right here. Oops. There's 1. I draw a vertical line right through there. Not a very good picture, but how many times does this line right here, x equals 1, hit the graph? Once, just once, right? One time. Okay. Look at part M. For what values of x does the function equal 3? So it's saying for what x values do you get a y value out of 3? And do y'all see there's only one place? It's right here. What's the x value that corresponds to that? 5. And you know that from the point, right? So here, for what x values do we get 3? X equals 5. Let me erase some of this because I've made a mess. Okay, last one. For what values of x does the function equal -2? So for what values of x, right? So I'm trying to figure out what x do I get a y value of -2? That only happens here, right? There's my y value of -2. So it happens at x equals 2. All right. That's it. You have a homework problem like that, all right? I think it's the first homework problem for this section. It's problem number 13. Let me see. Yeah. So where's it? Yeah, here it is. We just did number 12 out of the homework set, and you have to do number 13 for your homework, all right? Okay, the next thing we're going to do here is you're supposed to do all of these problems right here. Okay, so what I'm going to do is I'm going to try and do the evens. And again, I apologize that this is not the best projection, but it's what we've got to work with, all right? It's better than me drawing all these graphs one by one. So for each of these problems, what we're supposed to do, it's hard to see it here, but I will list it out. We're supposed to find the domain and range of each of these functions, the intercepts, that means the x and y intercepts, and then we're supposed to talk about this thing called symmetry. And I will get into that a little bit more when I actually start doing the problems, all right? So I will zoom, let me write this down on the side. We want, for part A, we want the domain of the function and the range of the function. For part B, we want the intercepts. So I'll put here x-intercept, y-intercept. For part C, symmetry. I'm just going to put sim. All right, so let's look at one of these. I'll zoom in a little bit so we can see it. Let's look at number 14. We're looking at number 14. I'll do some of the evens and you can do the odds. Okay, y'all see 14 there? All right, first of all, the domain. The domain. Y'all see these arrows? The arrows are important. The arrows imply that the graph continues to do that forever, right? So this graph goes like this and goes forever this way, and the graph comes down and goes like this forever. So when I think about domain, this is where I draw vertical lines and I say, do I hit my graph? So am I hitting my graph here? With vertical lines? Yes, right? How about to the left? When do I stop hitting? Never. How about to the right? Do I ever stop hitting the graph? Never. So the domain is everything, right? So this is, I'm going to write it as negative infinity to infinity. That's the domain. Yes?
Can you also just put it down as all real numbers?
You can put all real numbers, yes. But we're going to use interval notation mostly in this class. So I wouldn't take off, right? But I would get used to the interval notation. Okay, what about the range? The range is the same idea, right? But we turn